Hello everyone, this is Junaid here from Edureka and I welcome you all to this interesting session where we'll be looking into ensemble learning. So without any further ado, let's take a look at today's agenda. We'll start this session by discussing what exactly is ensemble learning and why do we need it. Following that, I'll be walking you through various techniques in ensemble learning, and finally we'll end this session by implementing ensemble learning in our machine learning model. Before we begin, do consider subscribing to our YouTube channel to stay updated on trending technologies. And also, if you're looking for online training certification in machine learning, check out the link given in the description box below. Alright, so let us now understand what exactly is ensemble learning. In the world of statistics and machine learning, ensemble learning techniques attempts to make performance of a predictive model better by improving their accuracy. Ensemble learning is a process using which multiple machine learning models are strategically constructed to solve a particular problem. This problem can be of a classification type or of a regression type. Ensemble learning models have three basic components. First off, we have a dataset. Here data is jumbled and sent to the machine learning model. The mixing of data is referred to as sampling, and we can either perform row sampling or a column sampling. Next, we have group of base learners. Base learners are machine learning models that can either be independent or dependent to each other. Here, every base model gives its prediction in accordance with the data that is fed to it. And finally, output or the prediction of all the base model is combined in a final model. Here, the decision is made based on the majority vote or by looking at their predictions weights. So moving ahead, now you might be wondering, when we already had state-of-the models like decision tree or SVM, then why was there a need of ensemble learning? Well, you see, ensemble learning helps improve machine learning results by combining several models. This approach allows a prediction of better predictive performance compared to a single model. This is why ensemble methods place a first in many prestigious machine learning competitions such as Netflix competition, KDD 2009 and Kaggle. What basically I'm trying to say here is that ensemble methods are meta-algorithms that combine several machine learning techniques into one predictive model in order to decrease variance or by improving the predictions. One of the most commonly or important terms used in ensemble learning is a bias and variance. Let us now understand each of them in detail. Starting off with bias. Bias error is useful to quantify how much on an average are the predicted value different from the actual value. The high bias error means that we have underperforming model which keeps on missing essential trends. Then we have variance. Variance on the other side quantifies how much are the predictions made on the same observation different from each other. A high variance model will simply overfit your training population and perform poorly on any observation beyond the training dataset. As you can see over here in the following diagram, the red spot over here represents the training dataset and the blue spot over here represents the testing dataset. Okay, the perfect model over here we can say it as low bias and a low variance. Now, as you can see over here in these three charts, the underfitting model is something wherein it does not perform well even on a training dataset. And as you can see over here on the extreme right hand side, the model has by-hearted every component. So the model would perform excellent on the training dataset, but on a new dataset or the test dataset, it will perform poorly. The best type of model over here is low variance and low bias. This type of models is called as just right model. And what happens over here is that we have some kind of error or noise which is present on either side of the classification or a regression task. Okay, so now that you know what is bias and what is variance, let us now move ahead and understand the various ensemble learning techniques. A quick reminder that I would like to say over here is that it is essential for you to know how decision tree works. Alright, in order for you to understand how decision tree work, you can check out our Edureka content and the link for it can be provided in the description box below. Alright, so let us now move ahead and see what are the different types of ensemble methods. You see, there are several different types of ensemble learning models, and following are the three of the most popularly used in the industry. We have bagging, boosting, and stacking. Stacking can also be referred to as voting. Let us now see each of them in detail. So let us now start off by understanding bagging-based ensemble learning. Bagging is one of the ensemble construction technique which is also known as bootstrap aggregation. Bootstrap establishes the foundation of bagging techniques. You see, bootstrap is sampling techniques in which we select n observation out of the population of n observation, but the selection is entirely random. You see, each observation can be chosen from original population so that each observation is equally likely to be selected in each iteration of bootstrapping process. After the bootstrap samples are formed, separate models are trained with the bootstrap samples. In real experiments, the bootstrap samples are drawn from the training dataset, and submodels are tested using the testing dataset. The final output prediction is combined across a projection of all submodels. So as you can see over here, we have a training sample, right? And then we can perform column sampling as well as the row sampling. And each of the samples are individually provided to these classifiers. This can also be a regressors, okay? And each of these classifiers are independent of each other. And whatever the output they give is finally passed on to this ensemble classifier, which gives out a final predictions over here. Alright, so let us now move on to the next type, that is voting based ensemble learning. We can also call this as stacking. You see, voting is one of the most straightforward ensemble learning techniques in which predictions from multiple models are combined. The model starts off with creating two or more separate models with the same dataset. Then a voting based ensemble model can be used to wrap the previous models and aggregate the predictions of those particular models. After the voting based ensemble model is constructed, it can be used to make predictions on a new data. The predictions made by the submodels can be assigned weights. Stack aggregation is a technique which can be used to learn how to weight these predictions in the best way possible. Okay, so as you can see over here, we have a couple of models like model A, model B, model C. And this model over here can be like something as simple as linear regression or logistic regression to as something as complicated as SVM, decision tree, random forest, or whatever model you would like to add. Okay, and each of these model will get the same data set. Okay, and whatever the output or the predictions that have been made, what's going to happen is this generalized model over here will try to vote. Okay, so if model A and model B are trying to say it belongs to class 1 and model C is saying it belongs to class 0, what happens is generalized model will consider the output of A and B because we have maximum votes, and that particular class would be something called as prediction. Okay, so this is how stacking works. So moving ahead, let us now understand boosting based ensemble learning. You see, boosting is a form of a sequential learning technique. Okay, the algorithm works by training model with its entire training set, and subsequent models are considered by fitting the residual values or error into an initial model. In this way, boosting attempts to give high weightage to those observations that are poorly estimated by previous models. When the sequence of these models are created, the predictions made by these models are weighted by their accuracy score, and the resultants are combined to create a final estimation. Models that are typically based on boosting can be something like extreme gradient boost, gradient boosting, adder boost, and many more. So as you can see here from the picture, this is basically a sequential model. Unlike bagging or voting where the models were totally independent of each other, here the next model or the subsequent model is dependent upon the previous model's weight. The combinations of these model is gonna be the final model. Okay, so as you can see here in the first training classifier, there are two values over here that is in the negative side were classified wrong, and one value here was classified wrong. Now this thing was passed as a feedback over here to this next model, and as you can see here we have these two objects or these two in the form of a correct class. But now the problem still remains that we have three more parts over here which are wrongly classified, and finally over here this part is correctly classified and we have a lot of mess over here. So as you can see here, all of the data points here are classified correctly in the final model. Now that we have a brief intuition about each of these techniques, let me now quickly show you how to implement each of these models using Python, and also let's see how we can implement them using built-in Python library that is sklearn. Okay, so let me quickly jump to my code editor here, and the code editor that I would be using today is going to be Google Colab. Alright, so here we are at Google Colab. So now what I'm going to do is we'll start off by working with bagging techniques, right? So let me quickly give a heading here. So first off, what we'll do is we'll import a couple of libraries, that is from sklearn dot datasets. We'll be loading the iris dataset. Let me quickly get that from sklearn dot dataset load. It's going to be import load iris. Okay. And apart from that, import pandas as PD, then import numpy as np. So far let's just have this, And now in order to load our data, what we'll do is we'll create this data is equal to load iris. And let's hit enter here. And let's see how this data would look like. So as you can see here, we have 3 columns, right? And each of these column represents a feature. So let's see what is this feature here. So that will be feature names. Okay, first off, we have sepal length, sepal width, petal length, and petal width. And let's also see the target names. Target names refers to the output. All right, and let's see what this would look like. So we basically have 3 classes over here: Setosa, Versicolor, and Virginica. So now let's convert this into a data frame. As of now, it's not in a data frame, it's in a form of an NumPy array, right? So let me bring this to a data frame. So here it will be d is equal to. So first off, we have sepal length, right? So let me copy that. Or we can also put this in a zip format, but just for the simplicity sake, let me just copy this. So the data over here will be data.data, and we want the first 50 rows and the first column. Okay, so this is for sepal length. Similarly, we're going to do it for petal length. Let me remove this. Okay, let me give a comma over here. Fine, and the data over here will be data.data, and now we're gonna have all the rows, and this will be 2. Fine, and now after that we'll have species. Species over here basically refers to the Setosa, Versicolor, and all that. So we'll have species. Okay, so it will be np.array. Basically, I'm going to use list comprehension here for I in data.target. So if I is greater than 0, if this is the case, then I want that particular class. Okay, so let me quickly give you a brief what I'm doing. So basically over here we have, as you can see, we have 4 features, that is sepal length, sepal width, length, and petal length and petal width, right? But as we are trying to understand how this thing works, I'm not going to take this entire data over here, all the columns. Okay, so instead of that, I'll take just sepal length and petal length, and we'll also keep it simple by keeping it as 2 class classification. And now if I execute this and just put d over here, so now let me convert this into a data frame. Okay, so it's pretty simple. So all we need to do is df, that is data frame, is equal to pandas dot data frame, and now we are going to pass a variable that is d. And now if I just put here df, so as you can see, we have sepal length, petal length, and species, which is equal to 1. Okay, so as you can see here, we have species 1 and 2. If I wanted, I could have changed to whatever I want, but yeah, we can just keep this for now. And here 1 represents Versicolor and 2 represents Virginica. All right, so now what I'm going to do is, if you remember how bagging works, first off we have a data set, and then what I'm going to do is, for that particular data set we have to randomize it, and that particular randomized data would be sent for different models. Okay, so now we'll try to randomize our data, or you can also say it as shuffle. So for this, it will be like df is equal to df.sample, and we want it to be df.shape. Okay, the reason why I'm doing df.shape, I'm just providing the length over here, and if I see df now, you'll see that it has been shuffled up. So if you can see here, we have all 1s over here and 2s in the next half or the next bottom, but here you can see everything has been shuffled. I can also see it from this index values over here. And now we'll create a data set for training, and then we'll also create a data set for test. Just keep in mind that, we'll create, see, we have 50 of class 2 and 50 of class 1. So what I'm going to do here is, I'll create a data set df underscore train, and this should be df.ilog, and let's say we will take all the values from 0 to 60, and I'll be having all the columns. Out of the 60 values, we'll just take random 10 values. Okay, so it will be sample 10. Okay, now if I print this df.train or df underscore train, so you will see here that, I get 10 values, but these are randomized. If I try to rerun this again, it will be a totally different value. Okay, so let me kind of rerun this. So as you can see now, initially it was 1 1, but now it changed. So let me do it once again. So as you can see, it changes every time. So similarly, what I'm going to do is we'll do it for test. So it will be df underscore test. This will also be equal to. So what I'm going to do is I'll just copy this over here and paste it. But here we don't want the values from 60, from 0 to 60. I'll take the values from 61 to all the way to 100. Okay. And we want all the rows. All right. So this is all there is about training and test data set. And now what I'm going to do is, out of this 10 values that is given to us by training data set, I'm going to take 5 values and I'm going to provide that as an input. Okay. So for this, I'll give it as df underscore test, or you can just, this is just a variable name. So it will be df underscore train, and we'll randomly take 5 values. And we'll keep replacement as true. Replacement as true means that, the numbers can repeat. We can also have replacement as false, but as of now, we'll take replacement as true. All right, so this is great. This looks pretty much great. And now what I'm going to do is we'll create our x and y. So x underscore test. So this will be df underscore tt dot ilog. We want all the columns, that is 5 columns, and except the last one, we want all the columns. Okay, so basically we want all the rows, and here apart from the last column, because the last column represents our y value, that is species, right? You can also set as dependent variable, and then I'll put it as values. Okay, and similarly I'm going to put it for y test. Okay, we want all our independent variables, and we want the dependent variables just the last one. Okay, so it will be -1 and then values, so that this gives us in the form of a numpy. And let me just create this. Yeah, so now what I'm going to do is, we have finished the 2 stages. First off, we have, if you remember right, we have the data stage, wherein whatever the data we have, we'll sample it up. In the next stage, we are supposed to provide whatever the data we have to our models, and whatever the data it goes inside the models would be random samples. Okay, so there will be random samples. So what I'm going to do is I'll just create a function here. So let's say def, and we'll give the name of this function as evaluate. And what this function accepts is a model name. And apart from this model, the model over here represents the name of the model or the object name. And then we obviously have to provide the input data, that is x test, or instead of x test, we'll just give it as x and then y. And what this model will do is, or this function will do is, it will just fit. We want our x and y data. All right. So to make you understand better, what I'm going to do is I'm also going to plot our model. So plot underscore tree, and we'll plot our model. In order to plot this model, we obviously have to import these libraries. So let me quickly do that up for you. So first off, we'll have to import from sklearn.tree, import decision tree, right? Classifier. And then we'll also need plot tree. Okay, so now we'll also import another library, that is from sklearn.metrics, import. Now this is basically to see how well our model is performing. We can just use accuracy score. And now to see how our how the values in the decision tree is being plotted, we can just use from. We have to import this. First off, we have to download this before we do that. So as this is a third-party library, we have something called as pip install mlextend. All right, and let me now execute this up. Okay, so this is already present in our code editor here. So what I'm going to do is from mlextend dot plotting, import plot decision tree regions, right? So it will just basically give where and all we have plotted our decision tree, right? So plot decision tree regions, and let me execute this up. Okay, now we'll come back to our function here. Okay, this plot tree would plot whatever the decision tree we have created. We want to show our plot, so it will be plt.show. Now to see how our decision tree would look like, so we'll have plot underscore decision tree regions, and for this we'll pass our x value, y value, the name of our model, that is model, and then we can also pass something like legends. So this would be just 2, and again after this it will be plt.show. Now let's also see the accuracy. Okay, So by any chance, if you try to get the predicted value, that is ypred, so this would be nothing but model dot predict and whatever the test we have. So it's going to be X test, right? All right. Just to give you a better enhancement, what I'll do is I will just print out Rx, print the actual value of Y. So Y test. And now I'd also like to print out the predicted value. So print, okay. And then finally, let's see the accuracy. So we'll have print accuracy score. This should be something like, we'll just use the function accuracy score, and now we'll pass out white test values and the predicted values. And finally, this would just return us the model. Okay, it would return us the train model, right? MOD here. All right, so we have to give comma over here. So the thing is, this has to be within the colon, and we have to provide a comma. Similarly, this has to be within this, and now we'll provide a comma, and let's execute this once again. Fantastic. So now what we're going to do is we are going to pass out some values. Okay, we are going to pass out the model, or we are going to create the model and then pass X and Y values. So first off, we'll say model 1. Okay, so decision tree DT1 or whatever it is, you can give the name, and we'll call it as decision tree classifier, and this goes here. So for this, we have to pass the X and Y value, right? So what I'm going to do is from here, right? So from this df.train dataset. So if you can see over here, from df.train dataset over here, I'm gonna call my values. I'll take just random 5 values. So it will be df underscore t. So it will be df underscore train. Okay, so this thing over here is gonna be test, right? Not train. And now we are gonna do it for the train. So let me execute this up. Okay, so now we'll do it for train over here. Df train will just take out random 10 values or 8 values. The number of values that you want to take is totally up to you. So we'll have 8, and replacement will be true. Okay, and now what I'm going to do is we need the X and Y value. So it will be X train. So this will be df underscore t dot iloc. Okay, we want all the independent features and the dependent features except the last one dot values. And similarly, we'll do it for Y. So this would be df underscore t dot iloc, all the rows, and then just the last column dot values. Now we'll just pass this inside our evaluate model here. So what we'll do is we'll just give it as bag1. Okay, this will be equal to evaluate. This is the function that we have created, and in this function we have to pass the object of a model. So it will be df that I'm going to give, and now I also will be passing out our X train and Y train. Okay, and let's execute this. Oh yeah, the reason why I'm getting this error is because here it says decision tree regressor. Oh yeah, this is because over here model.fit. Yeah, the reason why we are getting this error is because I'm passing here data frame. It's supposed to be the decision tree classifier, right? So yeah, so let me quickly execute this up now. Yeah, the reason why we are getting this PLT over here is because we haven't imported matplotlib. So let me quickly get that. Import matplotlib dot pyplot as PLT. And let's try to execute this once again, this particular function, and also this value here. So as you can see here, our model has perfectly predicted all the values right. So if it says 1, it just means that it's 100%. If you want me to show you that in a better way, what I'm going to do is I'll multiply this over here by 100. Okay, so whatever the values were there, all the values were predicted right. And this is how the decision tree had been plotted. And this is the decision tree. Now what I'm going to do is, this is our first decision tree. So let me just give here a comment. Now just like this, what I'm going to do is I'm going to create one more decision tree. for this, all I'm going to do is copy this part here. I'm going to copy the entire thing and we'll just paste it here and we'll change the names, secondary. All right, so out of 60 samples, it can take up any random 8 samples. Okay, and we'll just change this value here from bag 1 to bag 2 and rest everything remains the same. And let's execute this here. Okay, so even this is scoring 100. Let's see if our data set is same or not. So let me just quickly go through this. All right, so it's highly unusual for this to give the same predictions, but as we are using decision tree, obviously it's one of the most powerful models. So yeah, it's giving us the correct predictions. And finally, let's come down here and this would be like the third tree. Okay, so just like this, we can confirm one thing, that all the data aren't same. Okay, so as you can see here, the positions of the data have changed. So obviously all the data aren't same. It's just that the values have been predicted correctly, right? So let's try rerunning this once again just to see if we can get any wrong values. Okay, so this is a perfect example. So as you can see here we are getting accuracy as 100. Okay, 100%. So this is because all the values have been corrected perfectly. And now if we come down to this, you can see the accuracy over here is just 20%. Okay, that means only one value out of all has been predicted correctly. All right, so now this is a good example. So the predicted value over here or the outcome over here is going to be 2. Fine. And similarly, this has given out a correct prediction. Let me quickly run this once again. And as you can see here, over here as well, we have one value which has been predicted wrong. So this is a good example. As you can see, one is 100%, the other one is 820, and other one is 80. Okay, so we have created 3 individual models, and now the last step over here is to perform aggregation. So performing aggregation. You see, aggregation is all about giving a vote. Okay, so let's see what happens over here. So for this print, so we'll give something like prediction 1. Okay, and now what I'm going to do is bag 1, because this is just a model, right? So bag 1 dot predict. So let's say we'll predict the test values, right? So we'll give some random values. So it will be np.array. And over here, we're going to pass out this sepal length and whatever the features we have designed, that is sepal length and petal length. So let's take some random value, like say 2.5 and 4.9. Okay. And now we obviously have to reshape this because we're just passing one value. So it'll be dot reshape 1, 2. So this is going to be in a lowercase. It's a small typo that I've done. Okay, so this model is going to predict 1. So now what I'm going to do is I'll just copy this up here and we'll do it for all the 3 bags. So instead of bag 1, we'll give it as bag 2 and bag 3. All of them will be fed with the same data, and let's see what each of them will predict. Okay, this is great. All of the models are predicting 1. That means the final output over here is going to be 1. As the data set over here is small, that's why we are getting this accurate value. If the data set was to be pretty huge, we obviously won't be getting such an accurate value. And apart from that, let me quickly change this 2 and 3. Okay, and if we try to rerun this again, let's see if we are lucky, if we can get one wrong answer. Rerun this from the start. So yet again, we have got all the correct predictions. Okay, so now what happens is, as all the 3 values are 1, the maximum voting would take place. So the final answer would be 1. Now consider if one of them would have to give 2, right? And then we have 2 of them as 1. So what will happen is, as the maximum number of vote is 1, so the final output would be 1. So this is how bagging algorithm works. So moving ahead, let us see another technique that we have discussed earlier. Another technique that we have discussed earlier was about voting, right, or stacking. So the next one that we have seen was voting or stacking. So fine. So now what we are going to do is, let's see another technique, that is ensemble technique, that is stacking. Stacking is all about providing different kind of models, and then we'll perform aggregation just like this. Okay, so again, I'll import, let's see, various libraries that we can have. So from sklearn.neighbors, so we'll be using k nearest neighbors, that is knn, import k neighbors classifier. We can also have some linear model like logistic regression. So from sklearn dot linear model, import logistic regression. And apart from that, let's say we want something on naive so we can have, so from sklearn dot naive import multinomial naive Bayes. You can also take Gaussian naive Bayes. Okay, so multinomial naive Bayes, and we can also have Gaussian naive Bayes. And finally, we'll also take something like decision tree. So from sklearn dot tree import decision tree classifier. All right, and let's execute this. So now we have to create a number of models, that is M1. So it will be k nearest neighbor, so k classifier. And now we'll also have model like this, M2. So we'll have logistic regression. Then model 3, we can say we'll have multinomial naive Bayes. Then model 4 will be something like Gaussian naive Bayes. And let's say our model 5, this would be a decision tree classifier. Okay, so we have 5 models here. Now in order for you to work on decision, right, like if you want to work on voting or stacking, we have something called as voting classifier. So we have to import that. So to do that, we'll have from sklearn dot ensemble, or you can also say ensemble import voting classifier. Okay, and now we'll create a model. So model will be equal to voting classifier. We'll call the class, and now within this we are going to pass a list of tuples. Okay, so first off we'll have a list, and now we'll pass tuples. So we'll have the first model, obviously it was knn, and we'll just pass the name of the model, that is M1. Similarly, we can do the second model is logistic regression, so we'll give LR, and this would be M2. Let me change this back to comma and not colon. Fine. And now we have the third one as multinomial naive Bayes, so MN, and we'll give it as M3. And then we have Gaussian naive Bayes, GN, so it will be G4, M4. That's model 4. And finally, we'll give decision tree, and this will be model 5. Okay, so basically we are trying to pass a list of tuples. Let me give some space so that you understand this. Okay, and let me execute this. So now to train a model, so we'll have model.train, or it's going to be model.fit, right? So model.fit, and now we're going to pass xtrain and ytrain. So let's load our data set. So as we already have our value over here, that is iris data set, so I'm just going to use that. So what I'm going to do is we'll just copy this values here. So basically for voting, we don't have to perform randomization. So I can copy this data frame. So let me just see whether this works. So df, we scroll down and let's add a cell here, and let's see what this df represents. Okay, so this df represents all the values here, right? So basically what I need is x test, so x train, sorry. So the x train over here would be something like df dot ilog. Fine, I need all the rows, and the number of columns I need is the first two, right? So except the last one, I need all. And similarly for y test or y train, so this will be df.ilog. So I need all the rows and just the last column. Okay, we also need to import train test plate. So let me quickly get that as well. From sklearn dot model selection import train test plate. Okay, and let's quickly create an object for that. So let me scroll down and let me just copy this part here. Okay, now instead of x over here, I'm just gonna pass this value dot values, and similarly here, let me cut this, and instead of y, we'll just pass this value here. Okay, this looks good. Now let's execute the code, and now we'll just have to fit our model, right? So we'll have to do x train and then u and y train. All right, so this is basically telling us, what are the various values that this took or the hyperparameters that were involved. And now finally we'll see the score that our model have seen. So for that we'll do model.score and we'll just pass here x test and y test. So we just need the same value, right? So x train and then y train. So as you can see here, we're getting a 91% accuracy, right? So if I multiply this by 100, so you'll see we're getting 91% accuracy, and this is on a training data set. This is something which is expected. Now let's see how much accuracy we can expect on our test data set. So it'll be model.score. We have x test and then we also have y test. And let's execute this. So as you can see here, we are getting an amazing score that is 93%. So this means that our model is working absolutely fine. Okay, so we do not have overfitting or underfitting conditions over here, and our model is working perfectly fine. So this means that our model is performing very well. Almost all the values have been predicted fine. So now that we have seen two of the popular ensemble technique, that is bagging and voting, let's now move ahead and see the last algorithm that we have discussed in our slide, that is boosting. So let me quickly come here and give it a comment. So this would be boosting. All right, so over here what we're going to do is we are going to perform, or we're going to create this boosting algorithm. So one of the most popular boosting technique is add a boost classifier. Okay, so add a boost algorithm. So let's now see how we can implement this using sklearn. So this is pretty simple and straightforward. That is from sklearn.ensemble or ensemble import add a boost. And as we are performing classification, so it's going to be add a boost classifier. And the thing about add a boost classifier is that it performs only binary classification. Okay, so as we already have the data set present over here, what I'm going to do is we'll create a model, right? So we'll say add a boost classifier. So it'll be A, B, C, and we'll create an object of this add a boost classifier. And let's give number of estimators here, that is number of models that we want. So n estimators would be like 4, and we'll give it as random state. This would be 0. And now what I want to do is I'll do abc.fit, and we'll just pass our x test value, x train value, and then y train value. The reason why I'm not importing explicitly here is because we have already imported the data set here, right? So it doesn't make sense importing it once again. So let me kind of fit this. All right, and now let's predict, or now let's see how well our classification is working. So we'll give it as ypred. This would be abc.predict, and now we'll just pass here x test. Okay, and now let's see the score over here. So we can just say it as abc.score. We'll let's say something like x test and y test. So as you can see here, we are getting the value as 93%, which is pretty good. And if you want to see how much about classification we have done, or how many classes have been predicted right, what we can do is we can use this function here, that is accuracy score. So accuracy score, here we're going to pass the actual value, that is y test, and the predicted value, that it will be ypred. Okay, and let's see what would be the accuracy here. So we're getting the same accuracy. Basically, we are calculating almost all the values correctly. All right, so this is all there is about ensemble techniques. We have discussed 3 of them, that is bagging, boosting, and voting techniques. All right, guys, with this, we come to the end of a session. I hope you enjoyed and learned something new. If you have any further queries, please do mention them in the comment box below. Until next time, goodbye and take care.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!